What's up, everybody? Brian Mann here, Hands-On Auto Training. I want to share with you a case study on a 2010 Ford Fusion. I believe it was a no crank, no start, no communication with multiple things. I don't know the whole backstory, but I can tell you as I got started, we definitely had a no communication issue going on. Guys, this is a fun one where if you understand the basics of testing and understand how systems work, you'll be in great shape to go ahead and go fix the car. So that being said, this is an example of our premium membership meeting. Usually I have a case study or two sometimes, depending on what's going on, to share with the premium members. In that instance, we went over this live, talking back and forth, answering questions. So I have a few questions as we go through this. We'll see how you do. Let me know in the comments what you think, and we'll go ahead and get started here. So this is the case study here, 2010 Ford Fusion, no crank, no start, no communication with that PCM. I was called to program out. I was called out to program a used computer. Okay, used ECM. The tear tag information matched all that, no problem. I want to make sure you guys understand the original computer and the used one have no communication. So right away, I kind of feel like, well, it's probably not a computer issue. I mean, it could be, but you never know. So we installed the original computer to get us back to square one, and we had a no crank, no start situation. At this time, I'd like to ask you guys, where would you start? What would you do at this point, and why? You can answer this question to yourselves, and there may be many right answers. I don't have the answers for you. I can't talk with you right now, but just think about this. What would you do? I plugged into Ford Scan Tool, the Ford IDS. I took a look around. I did a complete vehicle DTC scan. And doing that complete vehicle DTC scan, I came up with no communication with the powertrain control module, ABS, power steering control module, restraint control module, APIM, that's your accessory protocol interface module, the HMC 4x4 module, all-wheel drive module. Note that at the time that I was looking at this, I was not sure which modules were on the network or what the vehicle is equipped with or not. I didn't think it had four-wheel drive, but I just want to make sure you have this baseline of where we're at here. So I went ahead and installed the DLC breakout box. And pins 6 and 14 are our CAN bus, guys. You guys should know this. Should be all familiar with this pretty well. This is good stuff. I want you to know, what should that resistance between pins 6 and 14 be? For those of you that have been following along with other things and checking out other people's channels, I know you know the answer to this. So let's just see if you know what it is. And you're right. If you're thinking we have two 120 ohm resistors in parallel like this, we should be reading what? 60 ohms. So let's take a look at this 60 ohms on this bus. What does this look like? Let's take a look. This is a network diagram from Ford, and I'm going to tell you right now, you have to be really careful on the types of diagrams you get and where you get them from. Guys, this is, I believe this is from AllData. If you look under description and operation of the CAN bus, you'll find a picture like this, and it's showing that we have some terminating resistors here in our cluster and also in our powertrain control module. But here's the thing, I want you to understand that the rest of this network may or may not make sense the way this is laid out. This diagram is not an actual real diagram of how the system is laid out. This is more or less maybe what we call a block diagram or just a general overview. So don't ever get hung up and looking at a diagram like this. Now let me get myself out of the way. There's that PCM terminating resistor. Sorry about that, guys. And high-speed CAN bus is here, and you got your medium-speed CAN bus over here, so all that's going on. So we have 120 ohms, guys, on this network. We should be having 60, all right? This here is more of an actual diagram. Let me get myself off the picture there. So here's what you can see here. This is more or less the actual diagram. We got our pins 6 and 14 running through the various modules. You can see right off the bat that we get over to our instrument cluster right here. And then also, if you go all the way through, you end up down at the powertrain control modules over here. It goes up and down and around depending on which systems you have or you don't have. This is how the system's laid out. Now, we also, let me see here. I want to zoom in a little bit. Is anybody familiar with what FEPS stands for? Check this FEPS line out. Well, FEPS stands for Flash EEPROM Programming Signal. This is kind of like something to tell the computer, hey, you're in programming mode. I'll be the first one to tell you, I don't know if the actual program goes through that network or on that line or not, but just something to point out there. That's what FEPS stands for. But taking a look at this module, or this diagram, and what we can communicate with, we could communicate with the instrument cluster. Originally, we had communication here to the cluster. And we could also speak with our occupancy classification module or occupant classification module. So that's good. but we couldn't talk to our APIM, and also we couldn't talk to the rest of the modules on this network. So if I blow up this picture a little bit, you'll see here that all the rest of these modules on this network, they're all dead. They're just not talking. So we have no communication with the powertrain control module, no communication with the power steering control module, and all these other modules are dead. So I think we can logically say at this point that we probably have ourselves some sort of break in the CAN bus right here. Now the hard part is finding out where is right here. So you see we got a couple different splices we can look at. This splice 333 and splice 334. If you go to a component location, this is on all data here, you can see here that we can find this splice 333 and 334 right down here on the floor over here. That's where I'm kind of going to be honing into to see, do I have my CAN bus signal coming through there or not? We can split the network there if there's a connector, which there really isn't. We got to go to components. There's no connector down there, just splices. But right now, this is awesome because I got a good idea where I'm going. Let's take a look at the next splice down the way, splice 332 and 336. And taking a look at these, going on a component search on all data, we come up here and find we've got our 332 and 336 are kind of up here on the transmission tunnel hump. And we know that we've got a problem here. Guys, this is interesting stuff, fun stuff. Take a look. We had to go digging. This carpet, or should I say the floor on this car, was so rotted out that we were trying to turn out the bolts for the seat, where the seat bolts in there, and it actually broke right out. I mean, this car should be scrapped at this point, but we know we got problems. And going on further, here is one of the splices right in here. Right there you can see that. That's one of the splices. And I had to dig the carpet up a little bit more and get in there and actually find that the splices had rotted apart and came apart. And what I did at this point is I just used a jumper wire to jumper these wires, you know, the white and blue to the white and blue, and get everything back the way it's supposed to go. And guys, we had ourselves our communication back at that point, so we were good to go. This is just a simple explanation of the CAN bus and how I went through a diagnosis. This was a pretty quick and easy one. I like quick and easy ones. They're the best. I'm working on a vehicle right now that's at a shop for a fuel pump control module for a 2013 Ford Fusion, not Ford Fusion, 2013 Chevy Malibu. I'm sorry, I was getting my Fords mixed up, and GM mixed up. Today I'm working on one, and somebody spliced the CAN bus in multiple spots by the transmission control module, and I think it's connector 115 underneath the hood. All kinds of crazy stuff. No communication with the fuel pump control module. However, I do have a data line signal back there. So, you know, I can see it on a scope. I have communication back to the fuel pump control module. Is it the right communication? I think somebody broke a bunch of splices in the harness and actually put them back together the wrong way. So this will be an interesting one. I got some snapshots of that. I'll go ahead and throw up here if I can. And you guys have a great day. You may see a video clip of that one tomorrow. If you have any questions, comments, or concerns, let me know. Like I said, this is the type of information you'll see up on the membership website. The core, I put some case studies up there. The premium, we'll actually talk about case studies like this as I go ahead and present them. I got some other stuff getting up there soon. Talk to you later, guys. Bye-bye.